Gradient, that will be the topic of today's video. So the learning goals for today, by the end of the lesson you'll be able to define a type of gradient and you'll be able to find a gradient from a graph. So what is gradient? Well, gradient is a measure of slope and it is the increase in y as x increases by 1 and it's the ratio of change in y over the change in x. So the formula we use for gradient you can see here. So we always write gradient equals rise divided by run. So rise is the change in our y value. So if we look at our Cartesian plane here, we've got our x-axis and our y-axis. So our rise is the change in y. So this would be the starting point of y, and this would be the ending point in y. So how much has y changed in that amount of time? That would be our rise. And our run is the change, oh sorry, that's not correct. That would be a change in x. So, sorry, ignore that. So the rise is the change in y, sorry. So y started here and it finished up here. So this here would be our rise. This is our change. So this is our rise. Rise. And our run would be the change in x. So this horizontal kind of change. This would be our run. So it's our rise over our run. How much has y changed? How much has x changed? Okay, so a positive gradient. The run is always considered to be positive when moving from left to right on the Cartesian plane. So if it looks like this, it's kind of sloped on this angle in any way, we know it's going to have a positive gradient. So the gradient is positive if y increases as x increases. So this is our x-axis and this is our y-axis. So we can see x is increasing, so we're going from 2, 3, 4, 5, if we look at that, corresponding y is also increasing, so it's also getting larger. It's gone from -2 all the way up to, it's gone from +2 all the way up to 5. So y has increased as x has increased, therefore we have a positive gradient. So let's calculate our gradient of this line here. So our gradient equals our rise over our run. So our rise is our change in x. So, sorry, our rise is our change in y. So y started at 2 and now it's at 5. So what is the change there? Well, that's 3. It's increased by 3. And our run is the change in y. So y started at 2 and it went to 4. So it's changed by 2. So it's 3 divided by 2 would be our gradient. So it's up to you there. If you'd like to leave it as 3 over 2 as a fraction, you can. If not, you can use your calculator and you can type that in. 3 divided by 2 can be your gradient there, 1.5. So that would be your gradient, and it's a positive gradient. Okay, so negative gradients. So a gradient is negative if y decreases as x increases. So you can see on our line here, we've been given 2 points. Hopefully that's not too blurry. You've got -2, 3. I'll just write it again so it's a bit clearer. Is our first point, and our second point is 2, -1. So we can see this is going to be a negative gradient because y has increased. So y started as -2 and then it's increased up to 2. So it's increased. What happens to y? Well, it's actually decreased because it started as +3 and now it's gone down to -1. So it's decreased. So we know it's going to be a negative gradient. So we're going to work out gradient. So gradient is rise over run. So rise is our change in x. So x started as 3 and then it went down to -1. So it's decreased. So we've gone from 3 to -1. So how much of a decrease is that? Well, it's decreased by 4. So it's -4. It's gone down by 4. And run is our change in x. So x was -2 and now it's gone over to 2. So this is our run. This was our rise. So how much has our run changed by? From -2 to 2. We can count it if you need to. 1. So we've got 1, 2, 3, 4. It's changed by 4, +4. So -4 divided by +4, we know we're going to have a negative number, and 4 divided by 4 is 1. So it's -1. So our gradient is -1. Okay, for these ones here, we've got 0 and undefined gradients. So a horizontal line, so remember horizontal like this, like a horizon, has a gradient of 0. So if you see a horizontal line, you say it has a gradient of 0. So for this one, this is our x, this is our y. Our gradient equals 0. It doesn't change at all. It's a horizontal line, so it has a 0 gradient. For the one on the left here, we've got x and our y. It's a vertical line, so that's straight up and down. It has an undefined gradient, so we can't actually say what our gradient equals. So we'd write gradient is undefined. Okay, so that's 0 and undefined gradients. Okay, sorry, I did actually record this slide already, and then I pressed a button and everything disappeared, so I'm just going to re-record it. So if I've jittered a bit, that's why. So A is our green line here, B is our purple line, C is red, and D is blue. Okay, so our worked example, I probably should have read that for a start. So label each of the lines below as having gradients that are either positive, negative, 0, or undefined. Okay, so positive, negative, 0, or undefined. So we'll start off with A. A is our green line. So remember, our gradient is our rise over our run. So our run is our change in our x value. And obviously as x increases, so as we go this way, what happens to y? So as we move this way along our line, as we move from left to right, is x getting bigger or smaller? Well, as we move left to right, x is actually getting smaller. So that means it's a negative gradient. So A is a negative gradient. Okay, B is our purple line, and it's a vertical line. And we know from our last slide that vertical lines have undefined gradients. So B is an undefined gradient. C is our red line. So as x increases, so as x is getting bigger, what's happening to y? Well, it's also getting bigger. As we move left to right, y is increasing in value, which means it's going to be a positive gradient. So we've got a positive gradient here. And lucky last is D, and D we've got a horizontal line, which means it has no gradient, it's not increasing, so we call that as a 0 gradient. There we go. Okay, so for these ones, we've got A and B, and we have to find the gradient of each of those lines. So we'll start off with A. So we know to find the gradient, so gradient, we know our formula equals our rise over our run. So our rise is our change in y value from left to right. So on the left here, it started here, and on the right here, it's changed to this. So we've been given a point, we've been given this point here, so we've been given 2, 3, and we haven't been given a second point, so we're going to find a second point. We can either use the end of the line here, or we could use another point here. We could use, for instance, our origin. So it crosses through the origin. So let's use the origin as our second point, which is 0, 0. So our rise is how much has our y value changed. So it's gone from 0 right up here to 3. So our rise would obviously be 3 because it's increased by 3. And our run is our change. So it's gone from 0 to 2. So it's 3 divided by 2. Again, you can leave it in the fraction, or you can type it into your calculator, and you get 1.5. So our gradient, 1.5, and obviously we've got a positive gradient because our y is increasing as our x increases. As we go from left to right, our x increases as we go left to right, and our y also increases as we go left to right. So for B, gradient equals rise over run, so rise over run. So rise is our change in our y value when we move left to right. So point on the left, our y value was 4. The point on the right, our y value is now 0. So it's obviously decreasing. So we're going to have a negative gradient on this one because it's decreased by 4. So it's negative 4 divided by our change in x, and x started as 0 and then it changed to 4, so that's positive 4. So negative 4 divided by positive 4 is going to give us negative 1. So our gradient in this one will be negative 1. And that's the end of this video. If you have any questions, please don't hesitate to come and ask me in class.